Hello, Pythonistas. We are here for the second talk of this track A. And here we have Darshita Chaturvedi, who is going to talk to us about creating a testing workbench for machine learning teams using just Python. So to talk a little bit about her, she's the co-founder and CEO of Atri Labs, where she's leading the development of a new full stack framework for web development. She has 5 years of experience working in machine learning and data science fields in various capacities, from graduate research assistant at MIT in USA to quant research at BlackRock as a US headquarter asset management firm. And she has completed her undergraduate education in engineering from the IIT Kharagpur in India, and dropped out from graduate program in management at MIT Sloan to work on her startup full time. So, and well, her favorite pastimes are painting and learning art history. Very interesting. So we have here a great leader and a very interesting topic. So I leave you people with Darshita.
Great. Thank you, Valerie. I hope everyone is able to hear me clearly.
Yes, we can hear you clearly.
Okay, great. Thank you. So, hello, everyone. My name is Darshita, and I'll be talking about creating a testing workbench for machine learning teams using Python. The examples used and the context of the discussion will be around machine learning and computer vision specifically. However, I hope that the knowledge gained about the open source tools that I'll be referencing in this talk can be used by you in any Python project. So a little bit about me. I'm the maintainer of the open source project A3 Engine, which is a full stack web development framework. A few weeks ago, we released a beta version of this framework, so it's ready to use. I'm also the co-founder and CEO of A3 Labs, which is the company behind this project. I've worked in machine learning and data science fields in academia and industry, as Valerie mentioned earlier. Um, after studying engineering during my undergrad, I worked in quant finance, and then I moved to academic research at MIT. I later dropped out of my graduate program to work on my startup full time. And one personal project that I'm very proud about is that I'm editing and managing the publication of a set of novels that my grandfather wrote over the last 50 decades. Um, so, okay, so on to the talk. I start this talk with a fairly controversial statement, but hear me out. So, as part of the A3 web framework that we are building, we we are also creating a high-level computer vision library as a utility of this framework. And while building and testing this library, we use OpenCV a lot. And of course, we love it, as I'm sure all of you here who have worked in this field. But several problems arise when we forcefully use OpenCV or any library for the matter for something that is never intended to do. And consequently, those feature sets would be limited and buggy. So the most significant one that I want to highlight is displaying media using IMShow windows. And this is largely the motivation for this talk. The three boxes that I have listed here uh, show some of the issues from OpenCV's GitHub repo that we have faced as well. I'll be referencing them to highlight how cross-platform testing becomes extremely difficult for computer vision projects when we use IMShow windows. So my team and I were building an algorithm that detects the position of the mouse cursor on an image and zooms in. However, OpenCV was exhibiting irregular behavior with different input devices. If we used a USB mouse, the cursor was detected as expected. However, while using the built-in trackpad of our laptops, there was a significant inaccuracy in the detection of the current cursor location because there was a delay in catching the events that the trackpad was transmitting. Moreover, for certain media types, but especially video, many times you might have noticed that I'm show window becomes irresponsive. Sure, sometimes it's easy to fix it through inefficient workarounds, such as increasing wait time. But at the core, the issue is that OpenCV's GUI gets stuck when CPU resources are tight. Besides, there are significant discrepancies in which piece of code works in which operating system. Here again, I can give an example. One of my team members had extended the zoom effect algorithm to also detect the keyboard cursor. While this code was working perfectly fine in Windows, no keyboard events were detected in macOS. Hence, cross-platform testing becomes really hard, and you're always unsure if your code will work on your team member's system. Some of the common ones that I've highlighted are discrepancies in media type, input devices, operating system, package distribution system, such as Conda, pip, etc. One common suggestion to fix some of these issues is to create custom wheels and build OpenCV manually at our end. But of course, this is not everyone's cup of tea. It's certainly not something that I'm very comfortable in. Let us now assume that we were able to surpass all the prior technical challenges through luck and perseverance. What comes next is an organizational problem. That is, how do we collect feedback from all stakeholders of a given project, both technical and non-technical? We face this problem most severely while working on an academic project with the US Department of Defense. We started sharing output snapshots over email, and this quickly ballooned into what I like to call snapshot jungle. There was no systematic way to collect specific feedback corresponding to each image and organize different people's opinions. Moreover, there was not sufficient version control of the test outputs to know if the newly improved model actually gives improved results for the test cases that you had already signed off on. So how did we address these problems? Well, we created a testing workbench that runs on the browser. I'll discuss why we think this is a good solution, but first, let me contextualize this discussion by showing you the workbench and describing how anyone, technical or non-technical, can use it for a computer vision project. So this is the multi-page testing workbench for a driving license OCR project. It is versioned with our machine learning code, and this is shared with the project team. So to get started with it, we have to log in. So let me go to the login page actually. Okay, I have my login credentials, so I'll use them here. And basically, you're able to authenticate who should have permission for accessing this workbench. All right. Once we log in, we see all the different test images that our team has already tried for this code. I want to highlight something. This is a very trimmed down version of the workbench that we are using. So we prepared this specifically for this demo. So this is not completely exhaustive, but it gives you an idea of how you can use a similar workbench. Okay, so on this page, we see that there were 15 test images that were tried for this driving OCR project. And there are three categories of reactions corresponding to each test image. And this is the name of the image. So this is like license 32. One of those reactions is wrong, other one is correct, and then warning. There's also this, these two sets of reactions, which basically mean that no one gave any responses. It kind of means that it was not reviewed. We can also see the number of comments our team has left for each image. So if you just stay on this page, we get a sense of the performance of our test images just by looking at the reaction. So we know that roughly 3 work well, and there are 3 that have egregious errors, and 2 are something that we can ignore for now. Note that in this page there is an option to add our own test image, and we'll come back to it later. But we'll first review each image individually. So we can click on the launch icon and we can view the individual test results. So let's do it for this because it has a lot of comments. So for license 13. Okay, so here we can see that for this driving license, our model did 2 things. It added bounding boxes around the fields that we had already defined. We had already told the model that we want to extract these fields from driving license. And they are name, license number, date of birth, expiry date, and address. Each field has a different colored box, and we can see the legend here. On the right, we also see the extracted text. Next is the reaction. So the nomenclature that my team usually uses is that if a test result is as expected, then we mark it done. But if there are some issues, but none that demand immediate rework, then we mark it as warning. But if it's egregiously incorrect, then we basically mark it with this loud red color. And finally, here we can see the feedback from our team members. Like the most important ones, like ignore this was just a dummy comment. But the most important ones to note here are that in this image, we can see that the bounding box is not accurate and it needs to be fixed. So specifically, you can see that, I don't know, like this one, for example, the width is like, it should be really tight. There shouldn't be, a lot of left padding here, so to speak. And the other thing that's mentioned in the comments is that the text extraction of the expiry date field is something that needs to be investigated. Because you can see here that it's NA, so we need to see why it's not, actually getting detected. Okay, so coming back to our slides. So one of the significant technical challenges with OpenCV Windows comes because of operating systems. Peter Wang, the CEO and co-founder of Anaconda, addressed this problem more broadly with any Python project. And he claimed that browsers have won the OS wars since they offer much more reliable support for running software. Specifically for our problem of displaying media, we know that browsers provide very superior and stable support for all input-output devices, such as keyboard, mouse, camera, etc. That's why we don't hear our web developer friends usually, complaining about how, a React code worked in Mac, but it didn't work in Windows, right? Because like browsers, they provide much better support, as I just mentioned earlier. And this statement was basically the inspiration behind this project. But the next question is, okay, I as a data scientist know that I should use browser, but how do I actually utilize browser using Python? Oops, sorry. That's where a 3 framework comes into picture. So this is a full stack web development framework built for Python developers. Using this framework, we can create multi-page applications by building the front end visually through, our visual editor, which looks something like this, and by writing the backend in Python. The framework also abstracts away many other time-consuming and difficult tasks. For example, the request response model is provided by default. What do I actually mean by that? So with other frameworks, backend teams spend a lot of time creating, documenting, and updating the REST API that they can share with their front-end team. This is a significant overhead for both teams. But the way Atri framework solves it is that it enforces an object model that is created and managed according to what you see is what you get philosophy of development. This also has other important benefits, such as security. So let's imagine a common scenario where our backend team mistakenly sends sensitive user details to the front end. Now, the Atri framework has pre-built guardrails that prevents sending any information that is not part of the object model. And besides, since front-end and backend share the same object model, there is a single source of truth. As a result, even if we use static type checking tools such as MyPy, we can preemptively detect bugs that result from inconsistencies between front-end and backend. Finally, other benefits are, lightweight front end and SEO performance. It is free and open source. There are many existing applications, such as the Workbench that we just talked about. Anyone who wants to use can clone the existing applications built using this framework, or we can create one from scratch. One very important point that I wanted to highlight is that it is a general purpose framework. So consequently, our users are building everything from e-commerce websites to internal applications for machine learning. And this is the reason why when we had to build an internal testing workbench to basically solve our machine learning woes, we used a Atri framework. So now let me take you through how one can actually customize this workbench. Again, if there is no need for customization, we can simply clone it and we are done. So till now we were talking about the app that was actually generated through the Atri framework. But now let's go to the editor and review how this was built. So very quickly, there are different parts to the editor. One is you see the different pages. So this workbench, for example, has 5 pages. Home, view test, new test result, and login. So home page is this, which basically lists all the different test images that we had. All the data here, by the way, that you see is this is all dummy data, because we actually feed the information through backend. So in your app, for example, we like if I go to this test page, I actually see the exact test images, not this data. But like when you're preparing front end, you want to have a placeholder. So that's what you see here. So like basically don't get spooked by that is what I mean to say. The other page is view test. This is a layout of what this is basically the layout. If you want to examine an individual test, then you see the input image here. You can also set which fields you want to extract, and you can you have this field for reactions, comments, and placeholders for all the different comments. Then in new test, this is the field that we see when we click on this. Sorry, this is the page that we see when we click on this add new test button. A new test result is the page that opens once we upload an image and click on run test. And then lastly, this is the login page. So there's lots to this specific framework, this specific workbench. But let's review other things in this editor very quickly. So if I click on this plus icon, I see different front-end components that I can use in my application. I see lots of templates. I see different images that I have used. And this is something that we are building right now, but it's basically resources section. Here you see different breakpoints. Which basically means that you can review how the same app would look in different screen sizes. So you get a chance to actually design something that's responsive. And if I click on any front-end component, then I see lots of styling related things. I can also, specify. I can basically manipulate this front-end component two ways. One, through front-end by basically, going to this custom section, and second, through backend, which is something that we'll look at just now. So, okay, let's take one very specific case. We are in new test result page, and we basically want to extract one more text field from our driving license images. So all we have to do is basically go here, copy this and paste it here. Let's change this to gender. And as I mentioned, this any front-end component can be changed from both front-end and back-end. We changed this text box through front-end, but we'll change this front-end through back-end, because basically what we want to do is display the information that our model is providing us. So I need to have a meaningful name for this component, because this will serve as the variable name in my code. So I changed it. Once I publish it, it will, these changes will reflect in my application. But note that these are dummy changes. Like a new field has been added, but we actually need to do something to provide data to this field, right? So let's go to our backend. Okay, so there's a lot here you can see on the left, but all you need to be concerned about is that when you start in a Three project, you get a lot of front-end code auto-generated. You also get you don't have to worry about how to set up communication between your front-end and back-end, because all of that is also auto-generated and it's saved in the same repo. The only thing that we have to do is, in our case, for example, we just want to change the backend for this one specific page. So where to find it is here. So within controllers and inside routes, we see all these different folders that correspond to all those different pages that I just showed you in the editor. And inside each page, you see a main.py file, and that's the only file that we have to be concerned about. So if I go to okay, so this is already open. Okay, great. So in this new test page, I can see that there is this function is already written, which is called handle event. So what this function does is when anything happens, like when someone interacts with your application, you can then take certain actions in response. So one of the things that will happen, as just to serve you a reminder, someone will upload images here and then they'll click on run test. And what we want to happen then is we want to send this image to our model. Our model would then send us, the information, like it would send us all the text fields, it would send us the annotated images, and we want to display those results, right? So that is why in this new test page, there is this conditional statement. It's written very simply in using if statement, that if run test dot on click, basically meaning that if someone clicked on run test, then do a few things. What do we need to do? We basically need to get data for these results by running this model, run driving detection. And the result is then saved in fin, which is a dictionary we get from OCR model that contains field name as key and extracted text as value. So for each field, we are checking, for example, for name, we are checking that if it exists, if this field exists in this dictionary, then display this, sorry, not display it, but save this in, save it in this variable after applying a bit of processing. So because our intention was to add a new field in our results, so I'll just copy this, paste it here, change this to sex everywhere here. Okay, so now my like this code will basically check if this field exists. The next thing that I need to do is send this in my query. So I'll just copy this and I'll make the same replacements. Okay, done. I'll save this. Now I need to transfer these results to my new test result page. So all I have to do here is go here, extract this. Need to be careful about indentation. Okay, and with this framework we get very brilliant intelligence. So we can just keep pressing. When we, as we're typing, we can see what are the different components that exist in our front end. So we can specify, we can set values. Like so I mentioned earlier that we can manipulate a component through both front end and back end. So this is exactly how we do that manipulation. So we had this text box. So I'll select that and I'll pass a custom text. And this text is actually the information stored in this variable. I save it. And now let's go back to let's refresh this application. Let's upload a new image. And run this test. Let's see if a new field was actually detected or not. Yeah, so we can see that we have a new field here. It was not detected well, but that has nothing to do with the framework, but it basically has to do with our machine learning model. And you can see here that this bounding box is highly inaccurate. It should, and like it shouldn't include the field label. So yeah, I can basically mark this as wrong, add a comment that fix bounding box, save this test, and it's now available here. So this is one of the ways in which we can customize this Workbench. The other way is simply if we say want to add a new page, then how to do it is go here, add a new page, just call it say guides and create. So now I have this blank page, and my intention here is that there are a few different moving pieces in this Workbench, and I want to give my users a step-to-step instruction guide around how to actually use this app. So all I have to do is I'll basically go here, I'll copy this nav bar, I'll place it here, and I'll add a new text box. I don't want it up here, so I'll maybe apply a lot of egregious punching. in the top and in the left. Maybe not too much. Okay, and very quickly edit it. How to correct. And yeah, that's it. We are done with this. So again, like coming back to our presentation, I hope the key takeaways that the key things that you take away from this talk are first that you should definitely consider moving away from I am sure windows to an organized testing workbench. You can do all sorts of customizations. For example, you might decide to add a new reaction category to refer to the test cases that you won't fix, that where basically things are working as intended. Um, Something that you commonly see in GitHub repos. The other great next step could be to add email notifications so that anytime anyone leaves comment or a reaction in the workbench, then you get like your team members get notified of it. And third is basically like if you're using a different model, then you can just change the model to let's say passport OCR. And I showed you I showed you where actually we get the results from a model. So all you have to do is refer to a different model there. So that is one of the primary takeaways. The other thing that I wanted to highlight is that using a web framework like this for Python, you get a chance to build your tech stack in Python entirely. One of the reasons why many of our data scientists turned founders like this framework is because they don't have to learn about maybe like React, all the backend frameworks, all the front end frameworks, but do all their build their data science products, build their websites using Python, a language that they're already comfortable in. And the third thing is, I myself was not a web developer, but all I had to do to create different applications, for example, just the one that I showed you, was understand one small front-end concept, which is Flexbox. And I can reasonably pass as a web developer because I can now make at least good-looking websites that actually serve a lot of functionality. So in terms of next steps, I like if you're interested, you can install a 3 framework, get started. As I mentioned, we have released a beta version just a few weeks ago, and there's a lot of activity in the community, and you can definitely participate. If you like the project, consider starting the repo. But in this repository of A3 Labs, you see like this A3 Labs engine specifically is the framework. But then there is this other repository as well called Demo Apps, which includes lots of examples from different domains. Everything from like e-commerce websites to internal apps like these, and we are adding more and more to that. So you can watch out the space for more. If you feel like if you create your own workbench and you feel that you face any specific issue, then you can raise those issues to us in our GitHub. If you're so inclined to share your work, then we have a lot of community applications as well. And we're specifically building a gallery to showcase all the work that everyone is doing around it. So feel free to connect with us. And so with this, I'll end this talk, and I'll thank you for listening. And you can find me on social media by this name. So please reach out if you have any questions or otherwise. Great.
Awesome. I don't know if you can hear me. I'm having some technical issues, but do you hear me?
Yeah, I can, Valerie, yes.
Okay. Awesome. So thank you very much for the talk. It's very interesting, this framework. I think very useful for many people. And we do have some questions for you.
Mhm.
So let's see. Um, the first question is, do you know Anvil? How does Atri compare to it?
Yeah, so Anvil is great, but it's mostly closed source. So that is one key distinction. But the other distinction, the other more important distinction that I wanted to make was um, this framework is a general purpose framework. It has like it's not limited to just data science or machine learning or internal applications or external applications. Um, so I feel like that's where um, we stand out a lot. And then I guess um, I've used Anvil, and I feel like the user experience and developer experience is very like it's very different between the two frameworks. So if you use two side by side, I think you should be able to see that difference as well.
Awesome. Thank you very much for that. And also, I would like to ask if somebody is willing to contribute to the repo, to the project. How could they start?
Yeah. So this also refers to a broader question around contribution in general to open source projects. So again, I want to reiterate first the common answer for all the projects, and then specifically to us. So one important thing is to remember is that all contribution is not code. So if you are creating like if you install and you use the framework and you are stuck somewhere, or you just have a question, even asking that in GitHub issues is a good contribution, because you are if you're facing it, it's very likely that others would be facing those similar issues as well. So that is very important to note, because contributing code comes at a later stage, but there are smaller things like these. So like improving the documentation, adding these different issues, asking questions. So apart from those common things, we also are adding contributing guide. So we'll give more specific examples, but most of those have to do with the fact that there are two different kinds of people who are using it, and if you can if you are a web developer, let's say you are a React developer, you want to add new components to the visual editor, that is a good way to contribute if you want to contribute as code. In data science side as well, if say you want a specific kind of chart that's not currently available in the editor, you can write a very simple uh, you know uh, backend for it. So I guess that gives you some examples around how people can start contributing.
Great. Okay, so we don't have any more questions. Thank you very much again, Darshita. It was a great presentation, very interesting project, and very useful tool, I think, for many people with this background in no knowledge of web development. And so, thank you very much, and see you all in the next talk in a few minutes. So, see you then.
Thank you, everyone.